Value in art refers to the use of light and dark. It can be a bit tricky at first to determine values as they are complicated by various factors such as color or environment. Colors come with certain values more or less already assigned to them. Blue is usually darker than yellow, for example. The environment that values are placed in also changes how we see them. A small light in a dark room can seem very bright, but that light might be hard to notice outside at noon. Think about the brightness level on a mobile phone in full sun. Most screens are unreadable even at full brightness. There is, though, an average range of light that is comfortable to the human eye that we can work with. But even in favorable conditions, most designers are limited by their materials. A painter can get no brighter than the white of the canvas or paint, and a graphic designer is limited by the range available in digital displays. The use of real light in art goes back to the beginning. Paintings and sculptures have been found deep within caves, far from the light of day. These prehistoric artists would have brought in their own light sources which would have given off a warm glow, since they would have used fire. In the Middle Ages, artists were able to control the amount and color of light through the use of stained glass. This was primarily an innovation in the use of color, but it did diminish the use of fire-based light in favor of natural sunlight, which would stream in through the larger windows. Closer to our time, artists like James Turrell have explored the nature of light. In his light experiments, his work pushes the limits of how we perceive color and light. He sets up light environments that challenge our eyes to adjust or to give us an otherworldly experience. In this piece, Turrell lights up a room with one color, and then leaves a hole in the ceiling so the viewer can see the sky. This piece changes throughout the day, but the color of the sky is almost never believable. Somehow, seeing the color of the sky seems unnatural. But since we are concerned with the value and not the color, let us note that in this example, one of the main reasons that the sky seems unnatural is because it is darker than the interior. Using real light is also important for how it is reflected or absorbed. For millennia, this has been understood by sculptors. Making images readable in real light is very important. The ancient Greek temple known as the Parthenon showcases this well. 3 types of sculpture were used: low relief, high relief, and in the round. Low relief, as seen here, only projects slightly off the wall. This works well for images that the viewer can get close to, or that has good light. High relief projects further out from the surface, so if the work is further away or can't be lit as well, it can still be seen. In the round work stands alone without a wall behind it. This work looks good in almost any lighting situation or distance. In most two-dimensional work, values are used to imply light. Joseph Wright of Derby, in his Moonscape, uses values to indicate the 3 aspects of light. First, he includes the source of light, the moon. The moon is painted in the lightest value. Next, his light source lights up the scene. This is the rest of the lit space. He shows this as a range of values from light to dark. Lastly, he shows shadows. These are places where the light cannot reach. Sometimes it is because the forms are facing away from the light, as in the back side of the bridge. Other times it is cast shadow, those areas where the light is blocked from reaching, such as the shadows cast by the bridge on the water. Let's back up a bit and address how light works when it hits an object. A core shadow is the total absence of light. It is the darkest part of an object. Since this is a sphere, It is located at the points that round away from the light source. A shadow is cast when one object is situated in front of another, blocking its light. In this case, the sphere is interfering with the light on the surface. Sometimes light is transmitted back onto one form from another. We call this reflected light. The light here is actually coming from the white surface below. It bounces off the surface and lands back onto the object. A local value is the characteristic value intrinsic to an object under normal light conditions. In this case, we can infer that the local value of the sphere is a slightly darker than middle gray. A highlight is the lightest part of a form, usually as a result of the greatest amount of direct light falling onto it. A value pattern is the total effect of all the values in a picture plane. When we add all of these values together, they create a value pattern. In this case, the pattern is one that tells us that this is a sphere. Without the indications of local value, highlights, reflected light, core shadow, and cast shadow, we would be looking at a flat shape rather than the illusion of a three-dimensional object. There are a wide variety of choices available regarding contrast. Sometimes it is dramatic, as we just saw in the Joseph Wright landscape. Other times the value range is limited, as in this painting of London Bridge on a foggy day by Monet. The word chiaroscuro means light dark in Italian. It was developed during the Renaissance as a way to bring out the volume of a form. It has been used for many other purposes, especially as a method to exaggerate drama, which is what the artist Rubens is doing here. Notice that unlike our sphere example, there is little to no local value in Christ's body. The values shift abruptly from highlight to shadow. Gradations are minimized. Closely related to chiaroscuro is tenebrism, and it is easy to confuse them. Tenebrism comes from the Italian word for dark, gloomy, or mysterious, and it is typified by images that are mostly dark, but contain places of sharp value contrast. In The Calling of St. Matthew, Caravaggio recreates a back alley scene where Christ is bringing light to a nefarious-looking crowd of tax collectors that are lurking in the shadows and probably up to no good. The chiaroscuro is present in abrupt, bright areas, but the overall tone still remains gloomy. Shading refers to any method used to create values. This is a pen study I did a number of years ago to capture values using line and ink. There are many other methods that depend on the media. With pencil, for example, smudging and using an eraser are equally valuable methods for creating value. Here's a drawing I did a long time ago of one of my cats, where I am using some of these methods. Texture evokes our sense of touch. It can do this in one of two ways. It can use actual texture, or it can simulate it. There are a few ways to achieve an actual texture. The first one is the most basic. It simply uses items that have texture. This is great in collage, but it is also common in sculpture. In this African divination object, for example, the designer actually used real objects such as shells to make an object rich with a tactile sense. Artists can also create their own textures that simulate the real thing. So, for example, this ancient Egyptian artist designed this perfume bottle in the form of a hedgehog. Although this vessel would not have the exact texture of a real hedgehog, it nevertheless is an attempt to approximate it. The same is true with this sculpture. It depicts Saint Teresa, the medieval mystic, in a swoon of ecstasy with an angel over her. The artist Bernini has attempted to simulate the silky clothing of the angel and the thick, coarse garb of Teresa. Also, hair, feathers, and skin are approximated. Although Bernini did his best to approximate the texture, the actual material is marble, which can only go so far in mimicking the materials. Simulating texture is an ancient art form. In the caves of Lascaux, prehistoric painters sought to simulate the hair of the animals around them. There are many different methods that artists have used to simulate texture. The artist Canaletto is using his skills as a painter here to simulate a variety of textures from plant forms to decaying concrete. Through his use of color, value, and paint application, he captures a rich variety of tactile sensations. In our day, computer-aided imagery allows artists and designers to simulate a wide variety of texture. This image recreates a scene from The Lord of the Rings. It is a view of Weathertop, the ancient watchtower described in the first book, The Fellowship of the Ring. The land and sky are almost convincing, though it all sits behind a smooth surface of a digital display. Space is hard to define because, quite frankly, it refers to a place between places or to nothingness. But we know that in our universe there is actually no such thing. The space between you and your display is filled with all kinds of things from molecules to dust particles. Even in outer space there is stuff. There are plasmas, magnetic fields, dust, electromagnetic radiation, neutrinos, and cosmic rays thinly spread throughout. But since all of these things are invisible to our eye, we think that they're not there. Out of sight, out of mind, as they say. Artists and designers struggle against this void. In two-dimensional art and design, there is both the surface and depth to be dealt with. The surface or picture plane is the designable area in which shapes, lines, colors, values, and textures interact. The leftover bits are negative spaces. Composing shapes onto a surface is basic to all two-dimensional work, and is almost all Kazimir Malevich is doing with this work. There is a measurable distance between each shape, and between each shape and the edge of the picture plane. That is what two-dimensional design is all about. But in order to recreate forms as they exist in real optical experience, artists have developed techniques to show an illusion of depth. The illusion of depth, or recessional space, can be achieved by using several techniques. Here's a painting I did of a gateway from the city of Zons in Germany that exemplifies 3 basic techniques of depicting depth. The first method is overlapping. This basic rule suggests that if something is sitting on top of something else, it must be more forward in space. Simply put here, the archway is overlapping the landscape. Next is size change. The further away something is, the smaller it appears in the image. Obviously, the trees are depicted smaller, and the buildings beyond them would never fit through the gate. yet they are shown as smaller. Lastly is vertical location. This just means that the things further away tend to work their way up into the composition as they diminish. For example, the base of the farther arch begins at a higher level than the closer one, and the base of the trees is higher still. The ancient Romans understood these, as can be seen in this fresco from the city of Pompeii. Note the overlapping forms, diminishing size, and that vertical location are all present. Beyond this, the ancient Romans began to develop a system of showing depth that they never fully systematized. It took over 1,000 years before this system was developed by Renaissance artists. This is called linear perspective. Linear perspective starts with the three methods just mentioned: overlapping, size change, and vertical location. But it adds three other elements. These three elements are converging parallel lines, a horizon line, and one or more vanishing points. All of these, when used properly, approximate how our eyes see space. This is an underdrawing I did for a painting using these principles. The first thing to notice is the horizon line. This establishes an edge beyond which the eye can no longer see. Of course, in real experience, horizon lines are due to the curvature of the Earth. Once the horizon line is established, then a vanishing point is placed. We'll come back to the vanishing point in a moment, but first it must be understood that key to making linear perspective work, there must be some sort of geometric form. In the case of my sketch, there are buildings. Now we all know that buildings are normally constructed as geometric shapes with right angles and parallel lines. In linear perspective, these angles that are actually 90 degrees will appear to be more acute, and the parallel lines will no longer be parallel. So if the angles are no longer right, and the parallel lines are no longer parallel, what are they? Well, this is where the vanishing point comes in. The easiest way to see this is in what is called one-point perspective, which is what is happening in this sketch. In one-point perspective, there literally is one point, or one vanishing point, where lines that would naturally be parallel converge. You can see that happening here. The lines that make up the street are not parallel as they truly are, but instead slope towards each other, and if the road kept going, they would converge at the vanishing point. Notice that not all parallel lines converge, only those that face away from the viewer. In one-point perspective, we see some sides of the shapes straight on, as in these two buildings. Masaccio is doing this in his painting Holy Trinity. There is one vanishing point, which is at the base of the cross. All of the parallel lines in the coffered ceiling would converge at that point if they were allowed to continue. But what if we are not facing one side of a form straight on, which is most often the case? We see objects at odd angles. That is where two-point perspective comes in. As you can guess, two-point perspective places two vanishing points on the horizon line. Now we have two places for shapes to recede to. The building in this painting recedes away from our view in two directions. We can see both sides at once, neither one straight on. So the sides and angles adjust so that the forms would meet at both vanishing points. There is one other type of linear perspective, which mostly occurs when the viewer is looking up or down on tall forms. This type of perspective adds yet one more vanishing point. This vanishing point is placed along the vertical axis, and all vertical lines converge to it. In this photograph of a skyscraper, there are 2 points which would merge along the horizon line, as we know from two-point perspective. But since the building is very tall, the vertical edges slope to meet at a third point up in the middle. Even though linear perspective is the best approximation to how we really see space, it isn't always used or preferred. It is difficult to take measurements from objects in linear perspective due to the distortions of the angles and lines. In such cases, another form of drawing is preferred. This is called isometric projection. As can be seen here, in isometric projection, all parallel lines stay parallel. They do not converge. Therefore, it is easier to take measurements from. So, it is preferred by engineers. Isometric projection was also used in Eastern art, as in this example. Notice that the table is tilted so that we can see both sides, and that the two sets of parallel lines representing the top stay parallel. We know that they are, and the artist has chosen to go with the measurable truth of the object, rather than the optical truth. There are two more devices that are sometimes used by artists to convey depth on a flat surface. One is called foreshortening, and you can think about it this way. The length of an object is shortened in order for it to come to the fore. Fore is an older word meaning in the front. So as we can see in this painting of the dead Christ, Jesus' legs have been foreshortened in order to make his feet appear to jut out into our space. Their length has been shortened and they appear to be tipped towards us. In this painting too, foreshortening is in effect. Notice the arm of one man and the spear of another. Foreshortening has been applied. They take up only a little of the space on the canvas, but appear to pop out at us illusionistically. The other device used is called atmospheric perspective. It is used to show vast distances through color and value change. It is also called aerial perspective and is primarily used in painting. It relies on things that we don't normally think about, but can see under the right conditions. What we don't often realize is that all around us there are particles of matter that are invisible to our eye. We don't see them because they are small and often so spread apart that our eyes can't pick them up. These bits of matter include the gases that we breathe and microscopic water molecules and dust particles. Even though we don't see these things up close, when they accumulate, we can sense them. So, for example, mountains can appear blue or purple in the distance because there are more molecules in the air between you and the mountain. These molecules reflect the blue light, and that is what we see. That is made obvious in this example. The further back the mountain, the bluer it becomes. But notice that it isn't just that the objects appear to change color, but that they also lose detail and value distinction. The mountain furthest back is also the least detailed and has the least shifting in its value across its surface. It is all of these things put together that make up atmospheric perspective.